Hello, welcome to this new video. This time I want to talk about DHCP starvation attacks. And before we get into it, we have to cover what DHCP is. Now, if you are new to IT or security, DHCP may be a new concept for you. If you've been doing IT, pretty much like any type of IT, DHCP is one of those cornerstones, foundational knowledge that you need to have in place to understand how things work digitally, right? DHCP touches everything. So with that being said, what I have here is my firewall, which is in this case a FortiGate firewall that I'm using as my DHCP server. I'm not going to go deep into DHCP, but you know that you can have a dedicated DHCP server that is outside the firewall device that you're using, or you could have it as part of the firewall depending on where you're using. So in this case, for the example that we're going to be doing, it is irrelevant where we have DHCP. Also, as you can see here, I have 19 clients that I'm using in my test lab, and DHCP is supporting those clients. So the thing is that, as you know, DHCP can be limited in the amount of IP addresses that it's going to give out to clients depending on your configuration. So let me come here. I'm going to log in for 1 second. Don't show again. And as you can see here, let me find my network interfaces. Right, then I'm gonna edit, and in this configuration I have DHCP enabled, as you can see here, and I created a segment of 192.168.170.0, and I'm assigning IP addresses within that segment from 192.168.175 to 192.168.172.50, right? So I'm just giving out 245 IP addresses. So, which means that I can support that many hosts in my network. And I'm not going to get into the broadcast IP addresses and addresses. I'm not getting into that. So let's leave out the little details and just talk about the broad picture. So I can support up to 245 hosts in this network. If you have, and right now, let me go back to the previous tab. Right now, I'm using 19 IP addresses, which says that, you know what, I'm going to be able to give out IP addresses to another 220 plus devices on my network, which is great, right? Depending on the size of the network, that's going to be a great thing. It's all one segment. Now, what about, and let me bring this network diagram here for 1 second. And again, this is an oversimplified network diagram that I have. And as you can see here, let me get my pen going. This is acting as my DHCP. And every time that a computer connects to my network, in this case, they're going to request an IP address from my DHCP server, right? They're going to send a DHCP request, and that request is going to be broadcasted to the network. And this guy right here, the DHCP server, is going to say, you know what? I am the DHCP server. Here is your IP address. And again, I'm oversimplifying this process. So the thing is that these computers, as they come and go, they're going to get an IP address from the from the DHCP pool, which is basically that pool that we saw in the previous screen. So let me get rid of this for 1 second and come here, and I can call this my DHCP pool, which is the available IP addresses that can be used to be given out to client devices in the network, and out of that pool I already assigned 19. As you know, the DHCP is dynamic, and depending on the configuration and the server that I'm configuring DHCP, these values or this leasing is what is called is going to expire at a certain time. I'm not going to be talking about that now. The point is that all devices in the network are going to require an IP address to access the network, and the DHCP server right here is going to be in charge of providing the IP address from the DHCP pool, right? Now, what happens if you have a device, or let me just talk about this before that. What about if you have too many devices in your network and the DHCP server does not have enough IP addresses in the pool, or enough available IP addresses in the pool to give out to the clients? What's going to happen is that, let's say that in this case I have 6 devices, right? And hypothetically speaking, the DHCP pool is only 6 devices. I only have 6 available IP addresses. And all of these guys, all of these computers are connected happily. What happens if I have one more computer that connects to the network and requests an IP address? Well, the DHCP server does not have another available IP address, so it's not going to provide an IP address to this client. So what's going to happen to this device? The device is not going to connect to the network. Simple as that. So what happens if another device tries to connect to the network? The same thing. It's going to connect to the network, it's going to send a request, and the DHCP server is not going to have anything. So what's going to happen is that either you expand the DHCP pool that you're using, you segment your network, you reconfigure your network, you create a new DHCP. There are many things that you can do. But the thing is that it could also happen that this device that you have here that has an IP address is turned off, right? When that device is turned off, that IP address is going to become available for the next device. So maybe, the IP address that was assigned to this device is going to be assigned to this device they're going to connect before. So how the algorithm works in the background is super interesting and super, it's very interesting and very powerful, actually, I should say. I remember I read a book on Wireshark many years ago, which talks about how the different protocols work, including the DHCP. And I must confess that was one of the best readings that I've had, or one of the best technical readings, because it goes deep into the ins and out of the protocols. Anyway, let me go back to my topic, right? So this is what happens. So as you could see here, if you have, let's stay again with 4 or 6 IP addresses, right? If you have a pool of 6 IP addresses in here, and you have 3 devices, everything in 5. But if you have 4 devices, you're still good. But what about if this device is a malicious device, right? What about if you have a user here who wants to not only take the IP address that it needs to connect to the network, but it wants to get all available IP addresses from the pool, so that when other devices try to connect to the network, like this one right here, they are going to get not a denial of service, because you're not denying the service here, but they're not going to get an IP address. Well, that is what DHCP starvation is. And it's one of the most successful, I should say, or easy to carry layer 2 network attacks that could happen. Now, the fact that it's easy to carry out, it doesn't mean that it's going to be successful, because it is also one of the easiest attacks to be detected. And depending on the configuration that you are using, one of the easiest attacks to be stopped right on the get-go, right? So, but let's talk about the concept and then we'll come back to this network diagram. So let me come here and close this. And I'm going to log in to my Kali computer so we can talk about dhcpstarv, the command. So here we are. There are many different tools attackers use to perform DHCP starvation. There are many. I'm going to be talking about only one today called DHCP Starv, as you can see right here. If you don't have it installed on your computer, if you're using Kali Linux, just type DHCP Starv and it's going to prompt you whether you want to install it. So the command is super simple. If you display the hub menu, you're going to see that the options are limited. So what you're going to do in this case, you are going to type the command. You need privileges for this. And you are going to assign the interface that you want to use for DHCP starvation. So I'm going to use sudo space DHCP starv -i ETH 0 because it is the interface that I'm using, right? Now, before I do that, let me bring over my other screen because this is going to happen fast. Let me log in one more time. And as you can see, I have 19 DHCP clients here. Just pay attention to this number and my list that I have. So I'm going to come over to my Kali Linux and I'm going to say, you know what? I want to starve the network of DHCP addresses because I'm going to do a, probably this guy is not happy that, he has to work overtime or whatever, right? I'm just making that up. And he's going to come over and he's going to hit enter. Well, you have to type in your credentials, your password. And notice what's going to happen. This device, in this case, is grabbing all the IP addresses that it sees available on the DHCP server, as you can see here, 15, 19, 21. But pay attention to this. IP addresses need to be assigned to a MAC address or need to be tied to a MAC address. What it's doing is changing the MAC address for each request. So it's not that it is requesting multiple IP addresses to be assigned to one single MAC address. It's creating different MAC addresses for the different requests that is sending out on the network. So I'm on 68. Let me come over here and let me refresh this. Now I'm up to 71 devices. If I come here to my devices list, you're going to see the MAC addresses that are being associated with those IP addresses that are being requested. Again, as you could see, it's changing the MAC address for each request. So let me come down here and stop this. There's no point. So if I let this run for a few more minutes, it was going to starve the network. It was going to consume the network of all available IP addresses. And out of 19 IP addresses that I have before in my network, out of the pool, now I'm using 71 IP addresses out of the pool, according to the DHCP server. Now, looking at this, you can see how this is one of the reasons why I said this is one of the very powerful and yet simple type of attacks to carry out, because you don't need to be a rocket scientist or need to have much understanding of how things work to make this successful, right? So there you go. If that happens, you're going to create in reality a denial of service attack, right? Because you're going to be denying new clients from accessing the network. Now, with that being said, how can you prevent this type of attacks? There are many different ways that you can prevent this from being successful. One of the many protections that you can use is at the switch level. In this case, you can implement DHCP snooping. And again, most reliable layer 2, layer managed, layer 2 and layer 3 switches are going to have some type of security controls that you can implement for that, right? You can implement DHCP snooping. And I'm not going to go into details of the ins and outs of DHCP snooping, but pretty much it's just a feature that is going to monitor for DHCP traffic and prevent any untrusted traffic that is coming from suspicious DHCP servers, right? So you could do that. You can also say, you know what? Heck, I'm not going to use DHCP. I'm going to use static IP addresses. And if you configure your devices to use static IP addresses instead of DHCP addresses, then you're going to solve that problem because you're not going to have that problem in the first place. You may be asking, who uses static IP addresses in a large network? Yeah, it's true. It's not common, but still out there. I wouldn't go that route though. You can also implement a network monitoring solution, right? That is going to sit right here. It's going to understand the entire traffic that is happening in the network, right? You're going to have a network monitoring appliance here that is going to keep an eye on what's happening. And any device that is going to be requesting multiple IP addresses or any multiple IP addresses going to perhaps the same port on the switch or any suspicious activity. And again, a lot of these network access control devices are going to have that enabled. Then it's going to be detected, and depending on your configuration, it's going to be stopped, right? So you could do that, get it right there. Depending on the switches that you are using, you can also implement IP source guard, and again, depending on where you're using, or you could also do, what else do we have here? A network access control, and you can create a ACL list. So the other thing that I would recommend you to do if you're not doing that is to do the very basic. I'm not going to say the very basic because it's very important. Like, one of the best practices is that if you're not using a port on a switch, disable it, right? And let me make this diagram more realistic. Most network environments are not going to have devices connecting directly to the network switch. They're going to be connecting to a network jack on the wall, right? And the jack is going to have a network going to a patch panel, and the patch panel is going to connect to the switch, right? So apply some simple, basic network security best practice. If you don't have a network, if you don't have a device connected to a network jack in your network, don't patch it in, right? Remember, there's a patch panel right here, and the patch panels connect to the switch. Don't patch it in. So that way, if you have an attacker that finds a network port available in your area, and they connect their computer, even if they connect the computer, that port is not connected to anything. So that is one of the most basics, but yet very effective security controls that you can implement. So you can set a lot of alerts. If you have a SIEM solution like Splunk or Datadog or one of the other guys, you can also set the configuration to alert you when something like this happens. So there are many different ways that you could do that. Now, that was it for DHCP Starvation. I hope you found this information useful. If you did, all I ask you for you is to click on the like button, leave a nice comment if you wish, and consider subscribing to my channel so we can, get more viewers and more supporters, and we can all increase our knowledge in cybersecurity. Thank you for watching this video, and I will talk to you on the next one.